Use synthetic division to determine whether the first expression is a factor of the second. If it is, indicate the factorization. If it is not, enter D and E. So in order to determine if this is a factor of this polynomial, we need to divide the two and see what the remainder is. If that remainder happens to be 0, then they are factors. If that remainder is non-zero, then they are not factors. And because this is a linear term with a leading term coefficient of 1, we can use synthetic division to make things easier. We just change this factor into a 0 by setting it to 0 and solving, or just thinking of taking the opposite of that value. Now we divide that into the coefficients of the polynomial in the numerator, which is 4x to the fourth plus 2x cubed plus 0x squared. We do need to be careful of a missing term there. Minus 2x and minus 1. So we bring the first item down for synthetic division, then we multiply it against this term, this value here. 4 times negative a half is negative 2. These add up to 0. 0 times negative 1/2 is 0. These add up to 0 again. 0 times negative 1/2 is 0 again. And now we add up to negative 2. Negative 2 times negative 1/2 is positive 1, and those add up to 0 also. So the result here, we do get a remainder of 0. So that tells me that this is a factor. So the x plus 1/2 is a factor of this polynomial. And more than that, we can say that this is the resulting polynomial if we divided it out. And this would be the constant of that polynomial. And these numbers here would be multiplied by increasing powers of x. So what happens is I end up with, I can say here that the polynomial 4x to the fourth plus 2x cubed minus 2x minus 1 is equal to this polynomial, which would be 4x cubed minus 2, but that's not done because there's no way a fourth degree polynomial is equal to a third degree polynomial. But if I multiply this by the original divisor, what I'm saying is the product of these two is equal to this original polynomial. You could use FOIL and check that if you like.